Welcome to the bilingual e-lecture session for diploma students. In this session, we are going to discuss about the geometrical properties of sections which belongs to Unit 3 in the subject Strength of Materials for secondary mechanical engineering students. So, in this session, we are going to see about what are thin cells, what is the definition, what is the failure of thin cells due to internal pressure, and we are going to derive the values for hoop stresses, longitudinal stress and tensile stress, and what are the dimensional changes occur due to the internal pressure in the thin cells, and we are going to see a problem also. Thin cylinders and spherical shells. These are all curved structures. Okay, the curved structural forms such as pipes, tanks, boilers and compressors, air containers show more strength by virtue of their shape more than the material. அதோட மெட்டீரியல் ப்ராப்பர்ட்டியை காட்டிலும் அதோட ஷேப் இருக்கு இல்லைங்களா, ஷேப்புனால அது என்ன பண்ணுது அப்படின்னா ஸ்ட்ரென்த்தாக இருக்குன்ற மாதிரி ப்ரூவ் பண்ணுது. ஓகே, தீஸ் ஆர் கால்ட் அஸ் ஷெல். இதை தான் என்ன சொல்கிறோம் அப்படின்னா நம்ம ஷெல்னு சொல்கிறோம். த வால்ஸ் ஆஃப் சச் ஷெல் ஆர் வெரி தின் as compared to their diameter. The walls of such cell are very thin as compared to their diameter. So, thickness to diameter ratio will be very small. Thickness to diameter ratio is very small for this case of thin cylinders and cells. These are some of the examples of thin cylinders. When the vessels are empty, they are subjected to atmospheric pressure internally as well as externally. Okay, you imagine it is a vessel. This vessel is empty. Okay, this vessel is empty. Okay, it is subjected to both internal and external atmospheric pressure. In such a case, the resultant pressure on the walls of the shell is nil. Okay, so atmospheric pressure is acting on the cylinder cells both internally and externally. So, the resultant pressure on the walls will be nil. But whenever the shell is subjected to an internal pressure, its walls are subjected to tensile stresses. The same cell now there is a internal pressure due to some load, okay, which is acting at the center of the shell. The walls are subjected to tensile stresses. If the thickness of the wall of cylindrical cell is less than 1/10 to 1/15 of its diameter, it is known as thin cylindrical shell. Okay, this is the thickness of the wall. If the wall thickness is 1/10 to 1/15 of its diameter, okay, wall thickness is 1/10 to 1/15 of its diameter, then it is called as a thin cylindrical shell. If the thickness of the thin cylinder is greater than 1/10 of the diameter, then it is called as thick cylindrical shell. Whenever a cylindrical cell is subjected to an internal pressure, its walls are subjected to tensile stresses. Whenever a cylindrical shell is subjected to an internal pressure, its walls are subjected to tensile stresses. If the tensile stress exceed the permissible limit, the cylinder is likely to fail in the following two ways: split up into the troughs, split up into cylinders, and split up into cylinders. Okay, a thin cell. Okay, it is a thin cell. There are some. It is subjected to a tensile load. The walls are subjected to a tensile load. Okay, If the load or tensile stress exceeds the permissible limit, there is a failure. There is a failure of the cylindrical shell. So, whenever the cylindrical shell is subjected to an internal pressure, it causes three types of stresses. First one is the circumferential stress or hoop stress. It is called as circumferential stress or hoop stress. Second one is the longitudinal stress. Second one is the longitudinal stress. And the third is the radial stress. Third is the radial stress. But in general, the thickness of the wall is very, very small. Radial stress is very small compared to hoop stress and longitudinal stress, and hence it is neglected. Okay. The radial stress it acts radially on the shell. Since the thickness is very small, it is very, very small. Okay, the radial stress is very, very small when compared with hoop stress and longitudinal stress. So, it can be neglected during the calculation. Now, we are going to see what is a circumferential or hoop stress. The hoop stress is the force exerted circumferentially in both the directions on every particle of the cylindrical wall. The hoop stress is the force exerted circumferentially in both directions on every particle of the cylindrical wall. This circumferential force is applied perpendicular both to the axis and to the radius of the object. It acts perpendicular both to the axis and to the radius of the object. It is called as the hoop stress. Assume that a thin cylindrical shell whose internal diameter is d and the thickness of the shell is being t. Length of the shell is L. Okay, and the shell is subjected to an internal pressure of intensity P. D is the diameter, T is the thickness, L is the length of the shell, and P is the internal pressure. Okay. FH is the circumferential stress or hoop stress. FH is the circumferential stress or hoop stress induced in the shell. Now, let us consider a longitudinal section through the axis divided the shell into two halves. So, this is the thin cylindrical shell. Now, we are going to consider a longitudinal stress which divides the section into two halves. Two halves are preached. What is the total force normal to the section? Force is nothing but stress or load into area. Stress induced into area. What is area? Here the area is the longitudinal area. What is the longitudinal area? D into L. It is going to be D into L. Resisting force offered by the section. Resisting force, this is going to be D and this is going to be L. So, D into L. Resisting force offered by the section is given by, force is given by, once again force is given by stress into area. Here it is given by hoop stress or circumferential stress into area. Hoop stress into area. Here the area is going to be the length and thickness. And it is on two places. So, it is going to be 2. So, the length, entire length into thickness. You take this cross section. Look at this picture. You take this cross section. What is going to be this one? This is going to be the length of the shell and this is going to be thickness. Similarly, on the opposite side also, we have the same thing. So, it is going to be 2 into thickness into L. This is going to be the area. Now, we can compare the two forces by equating equation 1 and equation 2. PdL is equal to FH into 2 into T into L. Therefore, FH is equal to PD divided by 2T. Okay. We can cancel this term. L get cancelled, 2T will go down. So, PD by 2T. Hoop stress is given by the formula. Hoop stress is equal to PD divided by 2T. Now we have to calculate the formula for longitudinal stress. What is a longitudinal stress? Longitudinal stress is the force exerted lengthwise, parallel both to the axis and to the radius of the object in both directions on every particle in the cylindrical wall. The hoop stress is perpendicularly applied, longitude is parallelly applied both to the axis and to the radius of the object. So the longitudinal stress is the force exerted lengthwise in both directions on every particle in the cylindrical wall. The same, assume diameter as D, thickness as T, length as L, pressure intensity as P, and the stress is FL. Longitudinal stress F suffix L kudukrom. FL be the longitudinal stress induced in the shell. Total force normal to section. Total force normal to section. This is the longitudinal stress. So force is given by stress into area. Stress into area. Here the area is going to be pi by 4 d square. Here the area is going to be pi by 4 d square. Resisting force offered. What is the resisting force offered? Resisting force offered by the section. This is the longitudinal apply pandrom. So it is going to be pi d into t. It is going to be pi d into t. நம்ம longitudinal apply பண்றதுனால என்ன எடுத்துக்கறோம் நம்ம development of surfacesல போய் the entire area எடுத்துக்கறோம். The entire area என்ன வரும் நமக்கு pi d. என்னது நமக்கு pi d circumference into thickness. This is the area resisting the force applied longitudinal force. Longitudinal force வந்து என்ன பண்ணுது இவ்வளவு ஏரியாவை நமக்கு வந்து ரெசிஸ்ட் பண்ணுது. So it is given by FL into A. Force is equal to longitudinal stress into area. So this is going to be F1 into pi d into T. Now we can equate the two forces. By equating the equation 1 and equation 2, we will get the value for FL. We will get the value for FL. P into, we will get the value for FL. Okay. P into pi into d square by 4 is equal to FL into pi into d into t. Pi we can cancel. We can cancel the two terms, and d square can be cancelled with this d. So the longitudinal stress FL is given by, we can bring this t downwards. Okay, so it is going to be P into D divided by 4 into T. Longitudinal stress is given by PD divided by 4T. P, we know the stress induced, D is the diameter, and T is the thickness. FL is going to be the longitudinal stress induced in the thin cylindrical shell. Similarly, we can calculate the change in dimensions. Okay, so the circumferential strain EH is given by, circumferential or hoop strain is given by del D by D. Okay, it is a circumferential. So circumference வரதுனால D நமக்கு என்ன வருது அப்படினா D. Change in diameter to the original diameter. Change in diameter to the original diameter. Longitudinal strain. Longitudinal வரும்பொழுது நமக்கு என்ன வருது நமக்கு throughout the length. Longitudinal வரும்பொழுது நமக்கு throughout the length வரதுனால it is given by del L by L. It is given by del L by L. Now we are going to calculate the volumetric strain. Volumetric strain is given by EV is equal to 2 into EH plus EL. 2 times the hoop strain plus longitudinal strain. This will give the volumetric strain of the object. Okay, for the thin cylindrical shell, the circumferential strain is given by del D by D. Longitudinal strain is given by del L by L, and volumetric strain is given by 2 times the hoop strain plus longitudinal strain. Stress induced in the cell is given by, P is equal to PD divided by 4T. BD divided by 4T. Strain is given by E is equal to del D by D. Del D by D volume of the spherical shell is given by pi dq by 6. Okay, this is for the thin spherical cells. This is for the thin spherical cells. The volume of the spherical cell is given by pi dq by 6. We will look at a problem. A water main pipeline of 1.5 meter diameter and 15 mm wall thickness is subjected to an internal pressure of 1.5 Newton per mm square. So, it is a main pipeline of a water supply system. Okay. The diameter is 1.5 meter, D is 1.5 meter, and the wall thickness is 15 mm. Wall thickness is 15 mm. It is subjected to an internal pressure. It is subjected to an internal pressure of 1.5 Newton per mm square. 1.5 Newton per mm square. Calculate the circumferential stress and longitudinal stress induced in the pipe. Calculate the circumferential stress and longitudinal stress induced in the pipe. Circumferential stress is nothing but the Hooke stress. So, what are the given data? Diameter of the water main pipeline. Diameter of the water main pipeline D is equal to 1.5 meter. இது என்ன கன்வெர்ட் பண்ணும்? mm க்கு கன்வெர்ட் பண்ணும். 1500 mm. 1 meter is equal to 1000 mm. So, 1.5 meter is equal to 1500 mm. Wall thickness of pipe T is equal to 15 mm. Wall thickness of pipe T is equal to 15 mm. Therefore, the thickness is very small when compared with the diameter. என்னன்னா diameter வந்து 1500 mm கொடுத்திருக்காங்க. Thickness எவ்வளவு கொடுத்திருக்காங்க? 15 mm. So, it is a thin cylindrical wall. Internal pressure is given by 1.5 Newton per mm square. Internal pressure எவ்வளவு கொடுத்திருக்கோம்? 1.5 Newton per mm square. So, to find என்ன கண்டுபிடிக்கணும்? Circumferential stress or Hooke stress sigma h. Circumferential stress or Hooke stress sigma h and the longitudinal strain induced in the thin cylindrical wall due to the internal pressure. Due to the internal pressure, what is the longitudinal stress induced in the object? Del sigma L. இது ரெண்டும் நம்ம இப்போ கண்டுபிடிக்கணும். ரொம்ப சிம்பிள், டைரக்ட் சப்ஸ்டியூஷன் தான் இல்லைங்களா? ஸோ நம்ம என்ன வச்சுருக்கோம் அப்படின்னா, ஒரு தின் சிலிண்ட்ரிக்கல் வால் வச்சுருக்கோம். இந்த தின் சிலிண்ட்ரிக்கல் வால்ன்றது ஒரு வாட்டர் பைப்லைன். இந்த வாட்டர் பைப்லைனோட அவுட்டர் டயாமீட்டர் 1.5 மீட்டர். திக்னஸ் வந்து பார்த்தீங்க அப்படின்னா 15 mm. வெரி ஸ்மால் தின் இல்லையா? தின் சிலிண்ட்ரிக்கல் வால். இது வழியாக வாட்டர் வந்து சப்ளை பண்ணுறோம். வாட்டர் சப்ளை பண்ணும் பொழுது இந்த வாட்டர் என்ன பண்ணுது? It produces some internal pressure. It produces some internal pressure on the cylindrical valve, inner side of the valve. அதில் வந்து எவ்வளோ Hooke stress உண்டாகுது, எவ்வளோ longitudinal stress உண்டாகுதுன்னு கால்குலேட் பண்ணணும். So, Hooke stress already we have calculated the formula. The induced circumferential or Hooke stress is given by the formula sigma h is equal to PD divided by 2T. PD divided by 2T. What is P? Stress induced in the cylindrical cell. D, diameter 1.5 meter. This is going to be 1500 mm. 2 into thickness. What is thickness? 15 mm. So, diameter thickness என்ன பண்றோம் நம்ம mm ல கன்வர்ட் பண்ணி கொடுக்கிறோம். So, the Hooke stress is given by the formula sigma h is equal to P into D into 2 into D. By directly substituting the values, we will get the result. Hooke stress is equal to 75 Newton per mm square. Hooke stress is equal to 75 Newton per mm square. And similarly, the longitudinal stress induced in the cylindrical cell can be calculated. The induced longitudinal stress in the cylinder is calculated using the formula sigma L is equal to P into D divided by 4 into T. Sigma L, longitudinal stress, is equal to P into D divided by 4 into T, where P is the stress induced, D is the diameter of the pipe and T is the thickness of the pipe. T is the thickness of the pipe. So, P is 1.5, D is 1500, 4 into divided by 4 into 15. All the units, all the dimensions must be in mm. All the length dimensions must be in mm. So, 1.5 meter 1500 mm மாத்திட்டோம். இது 15 mm. So, என்ன வேல்யூ வருது நமக்கு? Longitudinal stress sigma L is equal to 37.5 Newton per mm square. 37.5 Newton per mm square. We have to take down the result. Result. Induced circumferential or hoop stress in the cylindrical cell sigma h is equal to 75 Newton per mm square. 75 Newton per mm square, and induced longitudinal stress sigma L is equal to 37.5 Newton per mm square. 37.5 Newton per mm square. So hoop stress is என்ன formula? Sigma h is equal to PD divided by 2T. Longitudinal stress அப்படினு என்ன வரும் நமக்கு? PD divided by 4T. இந்த ரெண்டு ஃபார்முலா என்ன பண்ணிக்கணும் அப்படின்னா நம்ம ஞாபகம் வச்சுக்கணும். இதை ஞாபகம் வச்சுட்டோம்னா ஈஸியாக கால்குலேட் பண்ணிடலாம். ஸோ என்ன பண்ணுறோம் அப்படின்னா இந்த செக்ஷனில் we learned about thin cylindrical cells. We learned about thin cylindrical cells. Thin cylindrical cells பற்றி லேர்ன் பண்ணியிருக்கோம். ஓகேங்களா? Thin cylindrical cells are subjected to atmospheric pressure on both sides. இன்டர்னலாகவும் இருக்கும், எக்ஸ்டர்னலாகவும் இருக்கும். Since it is not subjected to any additional forces, it is in equilibrium. It is in equilibrium means that there is no resultant stress induced in the object. There is no resultant stress induced in the object. Okay, first point. அடுத்து என்ன பார்க்குறோம் அப்படின்னா whether it is a thin cylinder or thick cylindrical cell அப்படின்னு பார்த்தோம் அப்படின்னா how to determine this one by means of the ratio 1/10th of t to 1/15th of t. 1/15th of d இருந்ததுன்னா it is a thin. If the value of thickness is greater than 1/10th of d, okay, then it is called as a thick cylindrical shell. Then what are the stresses induced அப்படின்னு பார்த்தோம் நம்ம. இந்த stresses inducedல மெயினாக ஃபெயிலியர் நடக்கிறது என்ன காரணம் அப்படின்னா 3 ஸ்ட்ரெஸ். என்னென்ன ஸ்ட்ரெஸ் நமக்கு? ஹூப் ஸ்ட்ரெஸ், longitudinal stress and radial stress. இந்த radial stress பார்த்தோம் அப்படின்னா radial stress is very small since the thickness is very small. அதனால radial stress என்ன பண்ணிடுறோம் நம்ம neglect பண்ணிடுறோம். We are considering only the hoop stress and the longitudinal stress for determining the safety of the system or during the designing of the thin cylindrical shell. So we have to use the two formulas. Hoop stress, circumferential stress is given by the formula PD by 2T, and the longitudinal stress is given by the formula PD by 4T. So this is related to cylindrical cells, thin cylindrical cells. இந்த இதை பார்த்தீங்கன்னா இதான் தெரியும் உங்களுக்கு இல்லையா? ஸோ இட் கேன் பி ஃபெயிலியர் எங்கே நடக்கும் அப்படின்னா இட் கேன் பி கட் இன்டு 2 troughs. 2 troughs கட் ஆகி விழுந்துருது. ஆர் இட் கேன் பி கட் இன்டு thin cylinders. சின்ன சின்ன சிலிண்டர்ஸ் என்ன ஆகிடுது நமக்கு வந்து அது பிரேக் ஆகிட்டு வந்துடுது. ஸோ the tangential force acting வந்து என்ன பண்ணுது அப்படின்ற load acting வந்து it leads to the failure of the cylindrical cells. Now we can see one more problem. A gas cylinder of internal diameter 1.5 meter and 30 mm thick has the maximum permissible tensile stress of 150 Newton per mm square. Find the allowable pressure of the gas inside the cylinder. This is the problem given to us. A gas cylinder of internal diameter 1.5 meter and 30 mm thickness has the maximum permissible tensile stress 150 Newton per mm square. Find the allowable pressure of the gas inside the cylinder. என்ன கொடுத்துருக்காங்க நமக்கு வந்து diameter D கொடுத்துருக்காங்க, diameter D கொடுத்துருக்காங்க, then thickness T கொடுத்துருக்காங்க, then maximum permissible pressure P கொடுத்துருக்காங்க. இதை வச்சு என்ன கண்டுபிடிக்கணும் அப்படின்னா allowable pressure. What is the allowable pressure of the gas inside the cylinder? So the given data, internal diameter of the cylinder D is equal to 1.5 meter. நம்ம mm யூஸ் பண்ணுறதுனால அது mmக்கு கன்வெர்ட் பண்ணுறோம். 1 meter is equal to 1000 mm. So 1.5 meter is equal to 1500 mm. Similarly, the thickness of the cylinder can be calculated, taken as T is equal to 30 mm. Thickness of the cylinder can be taken as 30 mm. Permissible tensile stress, it is nothing but the hoop stress is given by 150 Newton per mm square. 150 Newton per mm square. To find the allowable pressure P. What is the allowable pressure P we have to determine. So solution for the problem is like this. Permissible tensile stress or hoop stress H is given by PD divided by 2T. PD divided by 2T. Hoop stress is given by PD divided by 2T. Don't forget that the hoop stress is applied perpendicular to both the axes. And the diameter. So therefore, allowable pressure can be easily calculated using this formula. Allowable pressure can be easily calculated using this formula. So what is P? P is the allowable pressure, D is the diameter, and T is the thickness of the cell. T is the thickness of the cell. So we have to substitute the values. P is given by, okay, from this we can take P. P is given by, allowable pressure P is given by sigma H into இந்த 2T என்ன ஆயிடும் நமக்கு மேலே போயிடும். ஸோ நியூமரேட்டருக்கு போயிடுது. 2T இங்கே இருக்க D என்ன ஆயிடும் நமக்கு டினாமினேட்டருக்கு வந்துடும். 2T divided by D. 2T divided by T. So you substitute the value of sigma H. What is the value of sigma H? Sigma H is 150 Newton per mm square. Sigma H is 150 Newton per mm square. Sigma H is 150 Newton per mm square. Then 2 is the numerical value. Thickness. What is the thickness? Thickness is going to be 30 mm. Thickness is going to be 30 mm. And diameter. What is the diameter? Diameter is 1.5 meter and it is going to be 1500 mm. In the value of the direct substitute பண்ணும்பொழுது we will get the result P is equal to 6 Newton per mm square. P is equal to 6 Newton per mm square. So we go to take down the result. Result as allowable pressure of gas. Allowable pressure of gas P is equal to 6 Newton per mm square. 6 Newton per mm square. Unit மறந்துடாதீங்க. யூனிட் எழுதலை அப்படின்னா நமக்கு மார்க் குறையிறதுக்கான வாய்ப்பு இருக்குது. ஸோ டோன்ட் ஃபர்கெட் டு ரைட் த unit for each and every values given in the problem. Okay. So with this we are coming to the end of the session. In this session we discussed about what are thin cylindrical cells and spherical cells. What are thin cylindrical cells and spherical cells? What are the stresses acting on the cells? And what are the stresses reason for failure of the cells, and we derived some equations to calculate the value of Cope stress and longitudinal stress. Since the residual stress value is very small when compared with Cope stress and longitudinal stress, for designing cells we are neglecting the value of or neglecting the impact of radial stresses. Then we solved 2 to 3 problems using the Cope stress and the longitudinal formulas. So with this we are coming to the end of the session. Thank you.